Good day everyone. In this video we are going to talk about relative rates and how it works in real life. The purpose of this video is to make S2 student and S1 student to understand relative rate. As you can see here, we have our problem where we have the ruler against the wall. The aim of this is to determine the rate at which this ruler will slide against the wall going down. Given our values, where we're gonna as you can see here, this diagram indicates a right angle triangle. We have our x here, and then our r, and then our y. Given the value of x, which will be equals to 600 millimeter, and then given a constant or r, which will be 780 millimeter. From this initial condition, we can get the value of y using theorem of Pythagoras. Theorem of Pythagoras is as follows. Squared. Then substituting the values in this x and in this x and r, we can get the value of y. We're gonna have y is equals to the square root of r squared minus x squared. Substituting the values, we have 0.78 squared minus 0.6 squared. Here we're gonna have 7.8 squared minus 0.6 squared, which is equal to 0.49. Then we're gonna round off to 0.5 in meters. Given this, as you said, you have to find the rate at which this ruler slides down against the wall. We have to differentiate this theorem of Pythagoras. Differentiating the theorem of Pythagoras, we're gonna have this equation. We're gonna have r d over dt by r squared is equals to dt over over d over dt r x squared plus y squared. This one is out, guys. Differentiating this one, you know that this one r is our constant. It does not change with respect to time. It's always constant. Then we're gonna have 0. When we differentiate the other one, we're gonna have 2x dx over dt plus 2y dy over dt. Substituting the values, the value of x and y we got from the values, we will find the rate at which y decreases with respect to time, which is this one, which we are looking for. This one we are given, it is dx over dt is equals to 0.6 meters per second. Substituting these values, we have 0 is equals to 0.6, which is dx over dt, plus 2 the y we got, which is 0.5, and what we are looking for, dy over dt. By calculating this, we have 0.6 squared. We have 0.72. Negative 0.72 is equals to Okay, this value will give us 1, which will only write dy over dt. We have a negative answer which tells us that y is decreasing when x is increasing. As you see that our x is positive, and then on this diagram we say that we were looking for a value at which this point decreases, goes down, which will decreasing, and this other one increases. The value of x increases, the value of y decreases, and then this proves us that the answer we got with respect to time has to be negative, since y is decreasing with respect to time.